Okay, so right now I am going to target a few things like how a transition zone operates or how the mineralogy does change when we go towards Earth's interior. So, whenever we are going towards Earth's interior, the things are like that. There will be changes in phases, there will be changes in their structure as well. So, whether it is garnet or pyroxene or olivine, they all undergo some sorts of changes as the pressure and temperature, both of them, are changing with respect to the depth of the earth. Whenever we are going from the upper fractions of the crust towards deeper mantle, then definitely probably you have heard about a discontinuity which is known as Morovicic discontinuity, where the pre-existing phases near the discontinuity are like olivine, orthopyroxene, clinopyroxene, garnet, etc. And whenever they are changing its composition, like if I am trying to, or if I try to draw a line of changes that undergo mineralogically inside Earth, the changes bring about, or changes are brought about, changes of the phases, or are associated with changes in the entropy of the phases, changes in the volume or molar volume of the phases, etc. Obviously, whenever you are changing a phase, they can be correlated with their equilibrium pressure temperature dependence, or the pressure temperature line in a system, whether a phase is stable or whether a phase is unstable. Obviously, as in geophysical characteristic or aspect determination, we have seen that there are two types of waves, P wave and S wave, and they are typically associated with the changes of the phase, and that's how the velocity as well as the density of the phases do change with respect to whatever the phase changes, whatever is going to happen there. Now, from upper to lower mantle, the sequence of the aluminum bearing phases are plagioclase, spinel, and garnet. The structures inside Earth, whenever it is happening, like in case of olivine, when it is transformed into a much denser phase, that is spinel, and this happens afterwards 410 kilometer discontinuity, and the beta phase of the olivine can change into spinel phase. There will be changes in the structural characterization or structural configuration. However, the important thing is that the change of the structure of the garnet or pyroxene transforming into majoritic garnet, they also assist, or they can also be associated with these types of changes in entropy and volume and etc. etc. this solution could be multitudes, there could be multiple of changes or multitudes of changes in a single phase or something. Now if I try to write them down with respect to discontinuity, at 410 kilometer discontinuity, or rather at 410 kilometer, the typical olivine is transforming into beta phase. And at 660 kilometer discontinuity, the garnet changes into perovskite and woostite, etc. These changes, whenever are taking place in these zones, obviously the S and V and related configuration, that is dP dt, that is called the Clapeyron slope, it is associated with the del S by del V is changing with respect to the depth. Because of these changes, or because of these changes associated, there could be some volumetric expansion or volumetric contraction whenever these changes are taking place. Now at typically 410 kilometer discontinuity, the change of the volume expansion is positive, and that's how the density is lowered down, and there could be a change of the buoyancy, and that's why some of the substances might get afloat. On the other hand, in this line or this region, the density is increased, the volume is contracted, and this type of a typical contraction is going to change the phase into a much more denser thing. The garnet has a crystallographic symmetry which is 4 by m bar 3 2 by m, and cubic and octahedral sites can be associated with, and the garnet has a typical character is that it has homogeneous character in all over its structural lengths or structural directions or lattice directions. Beyond this 660 kilometer discontinuity, the spinel structure that was generated from garnet might change into MgSiO3, that is post-perovskite structure, as well as rock salt or magnesio-woostite, etc. The cubic structure is formed by an octahedral configuration, and the MgSiO3 component might also be composition illuminatic in character. A recent study that shows that the beta phase may be described as Wardsleyite, that is, whenever olivine is getting transferred to beta phase. And this Wardsleyite structure can contain a significant amount of hydroxyl in its structure. And this hydroxyl molecules, it is a typical connection is that the hydroxyl molecules might preserve at around water that might be 7 times those are in surface or in oceanic water or in oceanic area nowadays, or the present day scenario. Now obviously these changes or associated changes will be very definite or will be important to identify as how the changes are taking place, or how the characterization of the mineralogy as well as